Hello everyone, this is Ashish and today I want to focus on the most basic concepts of strength of material. Now in a video a few weeks ago, I discussed the stress strain curve. That concept is not the first page of the first chapter of strength of material. So you need some basic understanding to understand those concepts. Now my agenda with that video was to give you the most detailed and the most appropriate answer if that comes as an interview question, because that is a very common interview question. But my idea with this particular video is for everyone to understand the basics of strength of material. It does not matter which field you are from. I'm assuming that you are at ground zero, and even if you are a mechanical engineer or a civil engineer who has done well in your career, there will be few things when it comes to basics that you did not know about or misunderstood, or you just had a wrong idea. So absolute ground zero, we will start with what is stress. Now at this level, we will assume that you know what is force, and we will assume that you know what is area. Beyond that, let us understand what is stress. If you ask even a common mechanical engineer who has done 4 semesters of mechanical engineering and ask that person what is stress, the most common answer that you are going to get is force per unit area. Now that is a wrong answer. At least in a high level research oriented job interview, that is a wrong answer. That is incorrect concept. That is not stress. Stress, a proper definition would go something like, it is an internal resistive force developed within the material per unit area when applied upon by an external force. The magnitude of the stress is going to be equal to the magnitude of force applied externally divided by area perpendicular to the direction of that force. This is the proper definition of stress. And a lot of things to pay attention towards over here. Number one, I talked about 2 directions. You might have thought I talked about 1 direction. I talked about 2 directions over here. Number one, direction of force, and number 2, direction of the area. So let me explain things with a diagram to you. So we have a block over here, and then we are going to apply a force on it. Force magnitude is F, and as you can see, it is applied externally. This body, where is it? Is it in space? Is it flying in air? Okay, it is sitting on a surface. You might think that it is like hovering over the surface. Well, that's just incorrect drawing. Let's say this is the roughness of the surface. This body is going to have some mass. Now I'm getting to a little bit of senior secondary physics over here. If you're going to apply force externally, and there's nothing holding it, let us say friction right now is neglected, the force is going to give this body an acceleration. That is Newton's second law. If you are having a net external force, that is going to give you an acceleration equal to force per unit mass. So that is not strength of material. So one thing to understand about strength of material is that we are only going to consider bodies which are static. We consider more about the dynamic nature and the dynamic stresses that is applied upon on the body, or the body develops because of external forces, in a subject called machine design. But in strength of material or mechanics of solid, throughout the course, we are only going to consider static bodies. So the number one thing that we are going to do over here is to add a fixture over here. That means that it is fixed at this point. Now that means that it is maybe attached or bolted or maybe glued to a wall. And what does that do? This is my wall now. Well, again, using the evergreen concepts of Newton's, the third law of Newton says that every action has equal and opposite reaction. So using that, what you are going to get is a reactive force which is equal but in opposite direction. That is why if you're going to hold a body, you are going to apply this force. If you're going to stick a body to a wall, the wall is going to apply that force. And if the force becomes too much, it's going to rip it out. Then that means that that wall does not have as much capacity to apply an equal and opposite force. It has a limitation. And at that point, you get an unbalanced force in this direction, and thus you get an acceleration. Right now, our intention is to understand stress. So this force is applied horizontally, and to make things simple, this area is vertical. Let us say this is an area A, just to not confuse with acceleration, which is not going to come in picture ever again in strength of material. I'm just going to remove acceleration for now. Now stress, which is generally denoted as sigma, is going to be equal to force vector by area vector. So as you can see, stress is the ratio of two vectors. And what is a vector in the first place? Well, vector is a quantity which has magnitude and direction. So it has both the informations. It is having the magnitude and the direction. For example, I say I'm moving at the speed of 10 kilometers per hour. Then you have said that I am moving at a magnitude of 10 kilometer per hour. That means that every hour I cover 10 kilometers. That gives you a magnitude, but it means nothing without the direction. So in which direction are you moving? So velocity is a vector. Speed is a scalar. Another example would be distance is a scalar, but displacement is a vector. So I'm going to move 2 meters, that is distance, but I'm going to move 2 meters in that direction is displacement. I'm displacing 2 meters in that direction, that is again vector. So vector is going to have both magnitude and direction. Force, if you do not know, is a vector. It is having a magnitude and a direction. For example, when I tried to explain it to you, this force is acting on this body. Didn't I give you two quantities? I told you that magnitude is a F, and I also told you that the direction is this. So a force is a vector. Very few people actually pay attention, at least at a very preliminary stage, that area is also a vector. So this is an area. Let us say this is an area. This is the magnitude of the area, and very few people actually know that this is the direction of this area, and direction is given by perpendicular to that area. So area is also a vector. This is very important in fluid mechanics as well, because there is a term called flow rate, mass flow rate or volume flow rate. Now that is, if I'm taking incompressible fluid right now, so I'm just going to say V into A. Now over here, velocity is a vector and area is also a vector. And you need to understand the flow is perpendicular to that area. That is the area that is going to be considered over here. There's so many areas over here. You think this is the only area? This is an area. This is an area. This is an area. This is an area. There's so many areas crossing through that point, because again, this is a point force, right? So this is an area too. Imagine those lines crossing through this point, and this is an area too. But what area are you going to consider? I'm going to consider area which is perpendicular to the force, or I'm going to consider an area with the direction same as the direction of force. Now this is an external force. Now what happens within the body if I split it into two? This is where I'm going to break apart the body and see inside. The body is not actually destroyed, but let us say you're sitting inside the body. What happens inside the body? So again, this is the force that was applied, which is of magnitude F, and this is the area same, because I'm going to take the same section within the body, and this is true throughout the body, not only center of the body. The entire material creates this internal resistive force. So even though there's nothing like this fixed wall outside, within the body as well there will be resistive force, and that force is just equal to the external force. So I'm just going to call it Fr, and that just happens to be equal as F. Now the way stress is defined, stress is equal to force, which is internal resistive force generated by the body when external force is applied per unit area in the same direction as the force. Now that turns out to be force per unit area. Now this is external force. So ultimately, solving problems and numericals, you'll get the same answer, but the thing is that the concept is different than what you thought, and those are the things that will be tested in like high-level research-based jobs, masters, PhDs. Now let's understand vector for a moment. Vector is a tensor. Tensors are of various forms. There's zeroth order tensor, first order tensor, second order tensor, third order tensor. So a lot of people ask trick questions like, what's the difference between a vector and a tensor? When in reality, vector is a kind of tensor. So I'm not going to get into much detail because that is really a giant topic, but here are different kinds of tensors: zeroth order tensor, first order tensor, second order tensor, and we'll stop at that. A vector has one direction and one magnitude, and it is a first order tensor. Now think about a quantity that has zero direction but one magnitude. What do you know that as? We know that as scalar. A scalar is a zeroth order tensor. Now if you're having a vector divided by another vector or multiplied, any way goes, how many possibilities do you think there are? So a vector looks like this. Now what is this? For example, velocity is represented by ai cap plus bj cap plus c k cap. These are the three different magnitudes in three different directions. They are in total of three directions. Those are the three dimensions. If there is a vector in the middle, how much of it is in x direction, how much of it is in z direction, and how much of it is in y direction? You need three different quantities to actually define a vector. So that is one vector. And then there is another vector, let us say pi cap plus qj cap rk cap. Now if you are going to multiply or divide them, how many possibilities are there? So 1, 2, 3, 1, 2, 3, and then 1, 2, 3. There are total 9 possibilities. Now the reason this is important in our discussion is what we right now talked about as stress is equal to force divided by area, where both are vectors, means that stress is a second order tensor. This is a first order tensor, this is a first order tensor, and the operation of these two gives you a second order tensor because there are total 9 possibilities. So a stress matrix actually looks like this. So this is the force in x direction when taken against the area in x direction. This is the force in y direction when taken against the area in y direction, and similarly in the z direction. This is the force in x direction when taken against the area in y direction. This is when taken against the z direction. So this is a stress matrix which is having 9 different components. This is a second order tensor. Now if you are having another vector, let us say k, and you are having an operation, what you are going to end up with is a third order tensor, and you are going to have 27 different components in it. Not extremely important at this stage, but this is how stress works. So when it comes to stress, the most commonly known law is the Hooke's law. And Hooke's law says that stress is directly proportional to strain. You do not know what that is, so don't worry about it. We'll get to that later. Let's just understand more about stress for now. So what we will need now is a 3-dimensional object, because we are already talking about different planes. So as you can see, this is my 3-dimensional object, and then these are my coordinates. This is my ZX plane, this is my XY plane, and this is my XZ plane. I'm just going to remove these so that things are clearer over here. And this is my object in 3D space. Now I'm going to apply only one force in one direction, and this is going to be in X direction. Now let us say that I'm applying equal amount of force in both direction, because if you are going to apply unequal force, that will cause an acceleration by Newton's second law. And say, for simplicity, all of these areas are equal to A. This is a cube, so all the areas are equal to A. There would be many planes over here. There's one plane which is exactly perpendicular to this force direction, or the direction of area is exactly same as the direction of this force. Now there's also another area which is at a different angle. This is where the concept of principal stress is going to come into picture. That is a discussion for another day, but you get the point. There's so many planes that are possible. How many planes in total are possible? And the answer to that is obviously infinity. Through a point, infinite planes can pass, and this force is applied on a point. A line is crossing through a point. This is what we call a point force. There are two areas which are really important, and there are two areas which are really important because we are having a 3D space. So there's an area which is parallel to the force, or the direction of that area is perpendicular to this force. I'm talking about this area or this area. And then there's an area which is perpendicular to the force, or the direction of the area is parallel to the force, and I'm talking about this area. And then there's another area which is also perpendicular to the force, or the direction of that area is perpendicular to the force, and that is this area. Clear? So just to be clear, I'm going to make it in a separate diagram. This is one area, this is another area, this is another area. So these three areas are going to experience the same force differently. Let me show you. This is this area, this is this area, and this is this area. All are going to experience the same force differently. But as you can see, there are only two kinds of combination of force and area direction. One in which area's direction is same as force, and one where area's direction is perpendicular to the force. And thus we are having two different kinds of stresses. And you might be thinking that, oh Ashish, what about this area? What about area out of those infinite directions which is at a particular angle, let us say 30 degree? I will say that I will discuss that later, but a short answer is that you can resolve this force into two directions in which one is perpendicular and one is parallel. So there is always going to be two cases. If the force is going to be parallel to the surface, or there's a force that is going to be perpendicular to the surface. In the case where force is perpendicular to the surface, the stress is called a longitudinal stress. A longitudinal stress can be of two different kinds, tensile and compressive. This is a tensile force where I'm trying to pull it away. And if I'm going to compress it, that is called compressive force, and that is also a form of longitudinal force. And the second kind of stress is called shear stress, where the force is perpendicular to the surface. And think about it. This is a shear stress, and if I try to pull this table up, that is a tensile stress. If I try to push this table down, that is a compressive stress. So stresses are of two different kinds, a longitudinal one and a shear one. The displacement or the deformation that it is going to cause to the material is going to act differently. But right now, let us focus more on the tensile stress. So we are considering again a form of body that is called prismatic body. A prismatic body basically means that area of cross section remains constant longitudinally. All across the area is constant, say A. Now it is again going to be applied with a longitudinal load in the x direction, equal and opposite. Area is A. By now I believe everybody understand that what is going to be a longitudinal stress developed within it. You can see by the nature it is going to be tensile stress, and it is going to be equal to force by area that is perpendicular to that force. Let us say that this area is B, and what is going to be a shear stress if force was not applied like this, where force is applied parallel to the surface. So let us say that this is how the force is applied and this is how the force is applied. Now the problem with this is that this F and this F is going to create a net of 2F, which is going to again cause acceleration. Now that is why we are going to consider a static scenario where you are going to apply a force which is F on the top, and we are going to have a fixed support at the bottom, which is going to create a resistive force in the other direction. And this, my friends, is a situation of shear stress. This is the same situation where you're trying to pull this book, let us say, across this table, and some scenario where table is like friction enough to hold it over there. So over here the stress is going to be shear in nature, and it is represented by tau, and that is going to be equal to again the force applied. Now you're going to say, oh Ashish, but you said stress is equal to the force perpendicular to the area, but we are having area parallel. Well, that was longitudinal stress. This is shear stress. Shear stress is the force that is applied parallel to the area divided by that area. So as you can see, the direction of force and area are at 90 degree or are orthogonal. So this is called shear stress. I'm going to take shear stress more seriously some other day. I hope things are clear now. What is stress is clear now to everybody. I tried to break it down and make it as simple as possible, but you still have questions. The comment section is open for you. Go ahead and start a discussion. I'm going to end this video over here. Try and get my book, The Boy Who Did Not Sign. It is a fictional story based on my experiences of working in nuclear program, working my way up towards the space program, that is Indian Space Research Organization. And the book is very highly reviewed. People love it. It's a very fascinating, engulfing story. There are a lot of interesting experiences that I believe you want to experience through this book. Go ahead, go to Amazon, read the reviews, go to Flipkart, read the reviews. You can get paperback or ebook, and now even hardcover is available. And if you don't trust me, you can go and read a sample on Amazon and make your own decisions very wisely, just like you did to stick with this video. Thank you for that. If you hit the like button, that would help me even more. If you hit the subscribe, that would help you a lot, because these kind of videos are going to keep on coming. Thank you for watching. I hope you learned something new today. Hashtag LSNT down in the comment section if you did. I'm going to end this video over here. Thank you so much. See you next time. Till then, bye.